Welcome to new session of physics. In this class, we will discuss electromagnetic waves, property of electromagnetic waves, and electromagnetic spectrum we will discuss. Students, already we know that wherever charge is at rest, electric field produces. But wherever charge is in moving, it produces electric current along with magnetic field. When charge is at rest position, it only create electric field. When charge moving with uniform velocity, it create both electric current and magnetic field. It create both electric field and magnetic field. Where charges are moving with a constant speed, it produces electric field and magnetic field. What we know? Wherever one quantity, say electric field changes with the time, magnetic field produce. But wherever magnetic field produces with the time, they also produce electric field. Changing one field produces another field in the space. Already we know this concept. But electromagnetic waves concept can be arises due to oscillating a charged particle with respect to time. Charges are oscillating. If charges are going simple harmonic motion, or simply wherever charges accelerated, it create time varying electric field and magnetic field. If electric field changes with the time and magnetic field changes with the time, it create electromagnetic waves. The oscillating charge is responsible for electromagnetic wave. Wherever charge accelerated, their electric field and magnetic field changes with the time. Due to changing electric field and magnetic field, it is responsible for electromagnetic waves. Simply, the source of electromagnetic wave is nothing but oscillating charge. Wherever charge oscillating or charge accelerated, it is responsible for electromagnetic waves. Look at me here. I can take electromagnetic wave. What is source of electromagnetic wave? The source of electromagnetic wave. Source of electromagnetic wave. Source of electromagnetic wave. Electromagnetic wave is oscillating charge. Oscillating charge. If charge oscillating or charge goes simple harmonic motion, it is responsible for electromagnetic wave. Are you following me? Wherever charge accelerated mean if charges moving with a different speed or different velocity, it is responsible for electromagnetic wave. This electromagnetic wave either you can produce by artificially or naturally. Electromagnetic waves can also exist. We know that whatever lights are coming from the sun, these light we are calling electromagnetic waves. Then what are types of electromagnetic waves? How electromagnetic waves property can exist, that we'll see in detail. Before that, I said that electromagnetic waves can be produced artificially and electromagnetic waves can be comes from naturally also. The first experiment done on case of electromagnetic wave is nothing but Hertz. Hertz conclude that wherever charge oscillating from the mean position, it is responsible for electromagnetic wave. How it is? Whenever charge oscillating, their electric field changes. Wherever electric field changes, their magnetic field also changes. Due to that, electromagnetic wave can be produced. Look at me. Our point is how electromagnetic waves can be produced as a function of oscillating charge. The first experiment was done by Hertz. Our next concept is Hertz experiment on electromagnetic waves. Remember, which is the source of electromagnetic wave? Oscillating charge is nothing but source of electromagnetic wave. Remember this point. Look at me. Shall I take here? Hertz experiment on electromagnetic waves. Hertz experiment on electromagnetic waves. Hertz experiment on EM waves, electromagnetic waves. Electromagnetic waves. See here. Hertz was studied how electromagnetic waves can produce, and later it was confirmed by Maxwell. Maxwell also said that wherever charge oscillating from that point, it is responsible for electromagnetic waves. See here. Hertz experiment was very simple. Hertz conclude electromagnetic wave by taking LC oscillations. I mean by taking inductor capacitor circuit, he produced electromagnetic waves artificially. That we'll see. How experiment was there. See here. Experimental arrangement of electromagnetic waves. It is very simple. Look at me. This is very simple arrangement of Hertz experiment on electromagnetic wave. Very simple. This experiment consists of inductor capacitor circuit. I mean, see here, this second call induction coil, this second call induction coil, right? And this we are calling input. This we are calling input. Look at me. And two metal plates, say this is P1 and what are calling, this is P2, and one more arrangement, this we are calling capacitor arrangement, and this plates P1 and P2 with respect to two spheres S1 and S2, this we are calling transmitter. What are calling this? Transmitter, and a sphere with single loop, this we are calling receiver. Very simple. Experimental arrangement consists of an induction coil which is provided by input. I mean, wherever current can flow, in this one energy can store. That energy stored in an inductor can be given by half L square. See here, to the induction coil, two metallic plates say P1 and P2 are connected. In turn, P1 and P2 two spherical metallic spheres are connected. This spherical metallic sphere act as a capacitor. How they act as? This total arrangement. How it is act as a? This act as a capacitor. And a single loop with the two gaps, they act as a receiver for electromagnetic wave. Question is, how electromagnetic waves can produce? We know that wherever charge oscillating from that point, it is responsible for electromagnetic wave. Here, how the charge is oscillating? We know that when inductor capacitor circuit, LC oscillations, when a charged capacitor is allowed to discharge across inductor, electric field oscillations are produced. That electric field oscillations varying with the time. How it is? Look at me. Wherever input voltage is applied, so that this inductor carry maximum energy. It carry maximum energy. The maximum value of magnetic energy is gradually transferred to capacitor, so that electric energy can changes. I mean, when a charged capacitor is allowed to discharge across inductor, electric field oscillations are produced. During electric field oscillations, charges are oscillating with a simple harmonic motion. Wherever charges oscillate, then what happens? Electromagnetic wave can be produced. How the electromagnetic wave can receive to the transmitter? Like this electromagnetic wave can comes like this. How it is? When a charged oscillator allowed to discharge across inductor, electric field oscillations are produced. During that, electric energy can convert into magnetic energy, or magnetic energy can convert into electric energy. During that, electric field oscillations are produced, so that charge oscillating responsible for electromagnetic waves. And how the electromagnetic waves are there? Electromagnetic wave consists of time varying electric field and magnetic field, and which are mutually perpendicular to each other, and also perpendicular to direction of propagation of the wave. How it is? Look at me. Whenever charged capacitor allowed to discharge across inductor, here electric field oscillations are produced. Wherever electric field changes, their magnetic field also changes. During changing electric field and magnetic field, which is responsible for electromagnetic wave. How it is? When a charged capacitor allowed to discharge, here how the electromagnetic waves can comes? Look at me. Like this electromagnetic waves can comes like this. So one quantity we are calling electric field, and second quantity we are calling magnetic field. Look at me. Here it consists of both electric field and magnetic field. If one quantity is electric field, second quantity is magnetic field. So that here how the waves can come? The waves can goes with periodically. I mean, due to changing electric field, due to changing magnetic field, a new type of wave is produced, that we are calling electromagnetic wave, and this electromagnetic wave is perpendicular to both electric field and magnetic field. This is artificially. And artificially you can produce electromagnetic wave in this way also. When a high beam of electron incident on a target, there also electromagnetic waves are produced. Artificially you can say. Artificially how electromagnetic waves are there. But naturally how they comes? In the sun, always the charges are oscillating with respect to time, because in the interior of the sun, large amount of temperature available. Due to large amount of temperature, the hydrogen is oscillating from the mean position. Wherever charges oscillating, that electric field and magnetic field changes with the time. It is responsible for electromagnetic wave. I mean, electromagnetic wave, these are nothing but type of wave which is responsible due to time varying electric field and magnetic field, and this wave is also perpendicular to electric field and magnetic field. If one quantity is electric field, second quantity must be magnetic field. See here, if one quantity is electric field, second quantity is magnetic field. I mean, electromagnetic wave propagating in the medium, it consists of time varying electric field and magnetic field. Remember this. Then let us take what are characteristic property of electromagnetic wave. One by one we'll see. Next concept is characteristics of electromagnetic wave, or simply properties of electromagnetic waves. See here, in detail we'll see what are properties of electromagnetic waves. See here, how the electromagnetic waves can come. Let us take the heading here. Properties of electromagnetic waves. Properties of electromagnetic waves, EM waves. Electromagnetic waves. See here. Wherever charges oscillating from that mean position, how the electromagnetic wave can come? Look at me. Like this. Wherever charge from this point, charge oscillating like this, simple harmonically. Then how the electromagnetic waves can come? In this way, electromagnetic wave can come like this. If one component is electric field, second component must be magnetic field, like this way. Like this. This we are calling electromagnetic wave. If one component is electric field, second component must be magnetic field. One component is electric field, second component must be magnetic field, like this. And this electric field and magnetic field which are perpendicular to each other and perpendicular also direction of propagation of electromagnetic wave. Right thing. What are the properties of electromagnetic wave? That we'll see one by one. See here. Electromagnetic wave may or may not require medium for their propagation. In presence of medium, electromagnetic wave can travel. In absence of medium also electromagnetic wave can travel. So that electromagnetic wave doesn't require medium for their propagation. See here, first property what you can call? EM waves, electromagnetic waves doesn't require medium for their propagation. Medium for their propagation. Medium for their propagation. In absence of medium, in presence of medium, electromagnetic waves can travel. Look at me. Then, how the speed of the wave can be given? How the speed of the wave? The speed of the electromagnetic waves can be given by one formula. The speed of the electromagnetic wave can be given C is equal to 1 divided by how much? Mu naught into epsilon naught. Where this mu naught resemble to magnetic field, this E naught resemble to electric field. It is constant in magnetic field, mu naught, epsilon naught is constant in electric field. Where what is mu naught value? We know mu naught value how much? Mu naught value is equal to 4/5 into 10 raised to minus 7. What is epsilon naught value? 8.85 into 10 raised to minus 7. Later on this. So from taking both values, what is speed of the light? The speed of the light is of the order 9 into 10 raised to 8 meter per second. That is nothing but speed of light. I mean, electromagnetic wave can travel with speed of light. But this speed of the light can relate to maximum value of electric field and maximum value of magnetic field. See here, if this is nothing but maximum value of electric field, this we are calling maximum value of electric field and maximum value of magnetic field. This maximum value of electric field and maximum value of electric field can related by this equation. Speed of light is equal to, or speed of electromagnetic wave is equal to E naught by B naught. Simply, the amplitude of electric field to magnetic field, that gives the speed of light. That gives speed of light. Look at me. We know that two types of waves are exist. One we are calling transverse wave, second one we are calling longitudinal wave. I mean, mechanical wave can classify into two category. One we are calling transverse wave, second one we are calling longitudinal wave. Mechanical wave is the wave which may or may not require medium for their propagation, that we are calling mechanical wave. Electromagnetic wave is nothing but type of mechanical wave. So on that basis, mechanical wave can classified as a longitudinal and transverse. See here, transverse mean the component of the wave which are mutually perpendicular to each other. I mean, the material medium of the wave which are mutually perpendicular to direction of propagation of the wave, that we are calling transverse wave. Transverse mean this electric field and magnetic field which are perpendicular to each other and perpendicular to direction of propagation. How electric field and magnetic field can be changes? Electric field and magnetic field can be changes like this. I mean, material medium is here electric field and magnetic field. This electric field and magnetic field which are perpendicular to each other and perpendicular to also direction of propagation. So that this electromagnetic wave is a transverse wave. How it is? It is a transverse wave. It is a transverse wave. Transverse means the electric field and magnetic field. Transverse wave. Transverse wave. I mean electric field and magnetic field which are mutually perpendicular to each other. But look at me. Wherever electromagnetic wave can travel from one point to another point, it carry energy. How it carry energy? It carry energy due to electric field and magnetic field. The average of electric energy and magnetic energy, that is nothing but total energy of electromagnetic wave. See here, we know that energy is saved by electric field. See here, how to say energy saved by electric field, how to give? Look at me. Energy saved by electric field can be given like this. How it is? Energy saved by electric field is equal to half epsilon naught into E square. What it is? Energy saved by electric field. Energy saved by electric field. Shall I take it as even? Energy saved by electric field, or for my convenience, what I will take? I will take it is nothing but U1. What is U1? Energy saved by electric field. Because here two components are available. One we are calling electric field. Second one we are calling magnetic field. Right around this. Then magnetic energy saved by magnetic field. How much magnetic field saved by energy? That we are taking half. Mu naught into how much? B square. Mu naught into B square. Here average energy, when electromagnetic wave travel from one point to another point, it carry energy. That energy is nothing but average energy of electric field and magnetic field. Average energy of electric energy and magnetic energy. How to give average energy of electric and magnetic energy? Look at me. Shall I take here? See here. We know the total energy. Total energy is equal to E. Or total energy shall I represent? That is represented by U. U is equal to average energy of electric energy and magnetic energy. This we are calling total energy of electromagnetic wave. I mean, when electromagnetic wave can travel from one point to another point, this represents total average energy. Similarly, when electromagnetic wave can travel from one point to another point, it carry both momentum and energy. Not only energy, it also carry momentum. Wherever it carry momentum, it exert pressure whenever it incident. Whenever electromagnetic wave can incident, it create pressure. Initially, let us see what is momentum of electromagnetic wave and how much pressure can exert on a given surface. See here. Initially, when electromagnetic wave can travel, look at here. Let us see one more property of electromagnetic wave. See here. When electromagnetic wave can travel from one point to another point, it carry momentum. It carry momentum. How to define momentum? Look at me. Momentum of electromagnetic wave. Momentum of electromagnetic wave is equal to energy divided by speed. How to define momentum of electromagnetic wave? Momentum of electromagnetic wave is equal to energy divided by speed. But if it carry momentum, definitely it exert a force. According to Newton's second law, what are taking? So total force is equal to rate of change of linear momentum. Rate of change of linear momentum. But P is equal to U by C. Then how much force is exist? F is equal to D by dt. Keep it up same. D by dt. Then what is P? P is equal to how much? That is U divided by C. How much force can exist when electromagnetic wave can travel? This much force can exist. Due to force, whenever electromagnetic wave incident, it create pressure. Pressure exerted by electromagnetic wave. How to represent? See here. Pressure exerted by electromagnetic wave is equal to force divided by area. How to see? Force divided by area. Then how much pressure you can give directly? Force divided by area mean P is equal to F. F mean this value. How much? D by dt of what value? U divided by C into what value? Area. Look at me. This much pressure can exist. This much pressure can exist when electromagnetic wave can travel from one point to another point. Similarly, you can define intensity of the wave. I mean energy emitted per unit area, that we are calling intensity of the wave. When electromagnetic wave can travel from one point to another point, it carry intensity. But the energy emitted per unit area, that is represented by one more vector, that we are calling Poynting vector. Poynting vector is the energy emitted per unit area of electromagnetic wave is represented by one vector that we are calling pointing vector. Look at me. See here. How to represent pointing vector directly? The pointing vector I will discuss. Pointing vector. Pointing vector. Pointing vector means when electromagnetic wave can travel from one point to another point, it carry energy. The energy carry per unit area can be represented by pointing vector. The pointing vector can be represented like this. That is, pointing vector is equal to P or P dash I will take. Pointing vector is equal to 1 by epsilon naught. 1 by epsilon naught E cross B. This we are calling pointing vector. So, no need to derive this equation. Just remember pointing vector means wherever electromagnetic wave can travel from one point to another point, it carry energy per unit area. Energy per unit area can be represented by pointing vector. But look at me. We know that electromagnetic wave is nothing but the light which is coming from the sun. Light is coming from the sun. If light is coming from the sun, it has lot of properties. Lot of property means either electromagnetic wave can be reflected, either electromagnetic wave can be refracted, electromagnetic wave can be diffracted, electromagnetic wave can be polarized. It can be polarized. So, electromagnetic wave can exist lot of properties. What properties? See here, one by one property you can see. One more property, EM waves. EM waves. EM waves can be reflected. EM waves can be reflected. Can be reflected. Can be reflected. They can be refracted. They can be refracted. Similarly, they can be diffracted. Diffracted, they can polarize, etc. etc. property can exist for electromagnetic wave. What is mean by reflection? What is mean by refraction, diffraction and polarization property? That we'll see in the next class. Just remember, electromagnetic wave which is coming from the sun either comes naturally or comes artificially. It reflected, refracted, diffracted, get polarized. These are property of electromagnetic wave. And one more property of electromagnetic wave can exist. Wherever electromagnetic wave can comes, it consists of time varying electric field and magnetic field. And when electromagnetic waves they can come, it consists of a lot of charge property. Either it consists of electrons, it consists of protons like this, because charge is oscillating continuously. So that wherever electromagnetic wave can propagating medium, this wave is always neutral in nature. Electromagnetic waves is neutral in nature. Neutral means it doesn't deflect by electric field and magnetic field. Right or wrong? Doesn't deflect by external magnetic field and electric field. So that this electromagnetic wave is a neutral in nature. But look at me. We said that either electromagnetic waves is produced by artificially or electromagnetic comes naturally. There are 7 types of electromagnetic wave can exist. Let us see what are 7 types of electromagnetic wave. Wherever charge is oscillating with actually charge oscillating not only with same amplitude, it oscillating with a different amplitude. Due to different amplitude oscillation, there are 7 types of electromagnetic wave can comes. See here. Naturally or artificially 7 types of electromagnetic wave can become. Let us see those 7 types of electromagnetic waves. Either you can say gamma rays, X-rays, UV rays, visible rays, IR rays, microwaves and radio waves. These are 7 types of electromagnetic waves. See here. Now let us see types of electromagnetic waves. There are 7 types of electromagnetic wave can exist. Shall I see here? These are few properties, types of electromagnetic waves. Look at me. Types of electromagnetic waves. Types of electromagnetic waves. Right. 7 types of electromagnetic wave depending on amplitude of charged particle oscillating from its mean position. See here. First type of electromagnetic wave, that we are calling gamma rays. Gamma rays. Second one, X-rays. X-rays. Second one is X-rays. Third one is UV rays. UV rays. UV rays. Fourth one is visible light or visible rays. Visible light or visible rays. Fifth one is IR rays. IR rays. IR rays. Sixth one is microwaves. Sixth one is microwaves. Seventh one is radio waves. Radio waves. 7 types of electromagnetic wave can exist. Right? Wherever light is coming from the sun, how many types of radiations are coming? 7 types of radiations are coming. Those we are calling gamma rays, X-rays, UV rays, visible light, IR rays, microwaves and radio waves. See here, out of 7 types of electromagnetic wave, only one type is reaches to the earth. That part we are calling visible light. That we are calling visible light. Visible light only reaches to the surface of the earth. Rest of all 6 radiations like gamma rays, X-rays, UV rays, IR rays, microwaves and radio waves, those are blocked by ozone layer. These 6 types of radiation blocked by ozone layer, only one part of electromagnetic wave, that is visible light, is reaches to the earth. This visible light has a wavelength 400 nanometer to 760 nanometer. Right? See here, these electromagnetic waves can arrange according to their frequency and wavelength. See here, this gamma rays has the shortest wavelength and the radio wave has the longest wavelength. I mean, the gamma rays has the highest frequency and radio waves has the lowest frequency. On that basis, the electromagnetic waves can arrange according to their wavelength and frequency. That arrangement is called as electromagnetic spectrum. Electromagnetic spectrum means the arrangement of electromagnetic wave on the basis of frequency and wavelength, that we are calling electromagnetic waves. I mean, electromagnetic waves can be arranged according to their increase in wavelength and decrease in frequency, that we are calling electromagnetic spectrum. Simply, I will draw how electromagnetic spectrum is exist. Concept is electromagnetic spectrum. Electromagnetic spectrum. Electromagnetic spectrum. Right. Look at here. Electromagnetic spectrum mean what? The arrangement of electromagnetic wave according to their wavelength and frequency. How wavelength and frequency? They are arranged according to increase in wavelength and decrease in frequency. See here. The electromagnetic wave spectrum can be setted on a single chart. Single chart. Look at it. See here. On a single chart. Like this. Single chart means this should be according to increase in wavelength and should be of a decrease in frequency. Increase in decrease in frequency. See here. It has the shortest wavelength and highest frequency. Frequency should be increased like this and wavelength should be increased like this. 7 types of electromagnetic waves are there. What are calling? So this we are calling gamma rays. Gamma rays. Next one is X-rays. X-rays. Third one is what? UV rays. UV rays. Fourth one is visible light. Visible light. Visible light. And fifth one is IR rays. Fifth one is IR rays. And sixth one is microwaves. Microwaves, and seventh one is radio waves. So this arrangement, what they are calling electromagnetic spectrum. How they are? They are arranged according to increase in wavelength and according to decrease in frequency. See here, this we are calling electromagnetic waves, electromagnetic spectrum. I mean, according to increase in wavelength, according to decrease in frequency, that we are calling electromagnetic waves. See here, this electromagnetic waves, 7 types of electromagnetic waves, they have a lot of uses. So many types of uses are there. Mainly these gamma rays and UV rays, that are used for medical purpose, to diagnosis the human parts or to diagnosis other further studies. We are using the gamma rays and X-rays. Artificially we are giving. These UV rays mainly uses for bakery purpose. I mean to prepare the foods. We are using the microwaves and IRAs. The visible light has lot of uses. And the microwaves, actually the microwaves, whatever we are using in LED, whatever you are saying in the open the doors, there we are using the microwaves. Similarly, radio waves we are using to transmit the radio signals from one place to another place. From one place to another place, to send the signals either by audio signals or video signals. To send the audio signals, we are using the radio waves. So that for communication purpose and for medical purpose, the 6 types of electromagnetic waves along with visible light, we are used for various purpose. So this is discussion on electromagnetic waves, either characteristic of electromagnetic waves and uses of electromagnetic wave, and this is electromagnetic spectrum. Up to here, this chapter has been over. Thank you, students.